To get started is I'd like to spend a second and look at the calendar with you so that you have a really clear sense of how the next couple weeks roll out, because we are getting dangerously close to our first unit test. And we've got some deadlines that are coming up that are going to have a significant impact on your grade. So I just want to make sure that everybody's sort of marching down the same path together. So guys, today what we're going to do is sort of a two-part day. We're going to spend 15 minutes and we're going to talk about something that you've learned in 7th and 8th grade physical science classes. We're going to touch on it briefly because it is something we're going to draw on for the rest of the year, and I want to make sure we're all talking the same language. That's density. This goes fast. Then guys, after that, we're going to have the remainder of the day. Well, we'll spend the remainder of our day perfecting the labs that are then due on Thursday. You'll notice that I gave you a blank copy of this. If you don't need this, give it back to me at the end of the day, but I suspect that many of you will, so I figured I'd give you a blank copy so that you can turn in a perfect draft of this lab when it's finally due on Thursday. So guys, that'll be today. Then Thursday, we're back in lab. Guys, we're going to be doing another lab on Thursday. Understand that the write-up for Thursday's lab looks a lot like the write-up that we're perfecting today. So everything that you do well today will benefit you on Thursday. Then guys, on Monday, some of my students would suggest that this is actually probably one of the most valuable things that they've done in their high school career, because sometime back in junior high school, you had teachers start to say to you, be sure to study for the test. You remember that day? They never talked about studying for tests in elementary school, but in junior high school, your teachers just sort of, as you were walking out the door, said, hey guys, make sure you study for the test. But they never taught you how. And so guys, most of you sit down to study for the test and get very little done because no one ever showed you how to study. And so guys, we're actually going to spend some time on Monday. We're going to talk about how to study for the test that you have on Wednesday. And then guys, the remainder of the day on Monday will be spent a lot like the remainder of the day today, where you'll have time to also post-lab the density lab, which will then be due on Wednesday. So guys, lots going on in the next 10 days. Questions about any of this? Y'all okay? You're sure? Are we good? Can we dig in? Okay. So guys, let me get rid of this. I got to click on like 4 things here. So this goes away. This comes over here. This goes like this. And guys, here's what I need you to do. Well, actually, you know what? If I put that up, you're going to start drawing. Okay, guys, grab your labs. Grab the lab reports that you have that you've already started to work on. And what I'd like to do is I'd like to draw your attention to the data chart. If you would join me there, please. And that's section 4 of your lab. And you'll notice, guys, that as we said before, this was a quantitative lab, right? So you guys went into lab, and as a quantitative lab, you collected data. And guys, if you allow your eye to scan down that data chart, you'll notice that there's actually only 2 kinds of data that you collected. 1, 2, 4, and 5 were masses, and then number 3 was a volume. You'll notice that your masses were measured in grams, your volume was measured in milliliters. But guys, we sent you into lab last week, and we never talked with you about what any of these things mean. So guys, what we're going to do today is we are going to gather around these concepts of mass and volume. We're going to define some terms. Then we're going to bring mass and volume together in the form of what we call density. Then we're going to solve a couple problems, and then we're going to move back into the lab and help you perfect it. You get the idea? Okay, so guys, now copy this into your notes. Make it as wide as your page. And then guys, what you want to do is each one of these spaces, you want to make 3 lines tall. So make it evenly distributed as wide as your page. And then this is going to be 3 lines. And this is also going to be 3 lines. Bless you. Everything that you wanted to know about mass and volume, but were afraid to ask. You guys remember learning mass and volume in like 8th grade? A little, maybe. Well, if not, we'll review. Bless you. I can't believe there's already like nasty sicknesses going around. It's like the first week in September. Well, no, but there's like nasty stuff going around, like this like flu thing that is just smushing people. Like, it's not good. My son claimed he had it, but I think he was actually just tired from homecoming and didn't want to go to church. So he went anyway. He got miraculously better, though, when we then went out to dinner for his birthday that night. Sushi. As my daughter sat there and ate chicken fingers and French fries at a sushi restaurant. She's an embarrassment. Yeah, that one made it to Instagram. You guys ready? You good? We okay? All right. So, guys, these are the things that you need to understand about mass and volume. You need to understand, first of all, the units that we're talking about. Then we will talk about English units only because when we think about making measurements, we think about gallons and quarts and pints and pounds and ounces. And we're not going to do that in a science class. We're actually one of the only countries on the planet that still plays those games. But we will talk about English units simply because it's what we know. Then we'll talk about definitions. We'll talk about the metric units we'll use, and then the devices we use to measure these, although you already know those. So guys, we're going to talk about volume, and we're going to talk about mass and weight. Now guys, if you've taken physics, and I think most of you have, you know that there's a difference between mass and weight. They are not the same, but we are going to use them interchangeably. So if you learned about the differences between these two things, don't get caught up in that in here. We're going to use them interchangeably. You'll find that in a lot of the sciences that's the case, so we're not going to draw a distinction. So we're going to go volume, we're going to go mass and weight. So guys, let's start with volume. Let's work our way across. We'll give you some context for this, and then we'll move on from there. So guys, when we measure volumes in English units, what are our units? Quarts, not liters, gallons, cups, pints, teaspoons, tablespoons, hogsheads, bushels. Guys, the English unit is a train wreck. You're probably most accustomed to things like cups and quarts and gallons and teaspoons and tablespoons and pinches and things like that. And guys, it's just an absolute mess. But regardless of the units, we need to talk about what volume is. So when we say something as the volume of a cup or a quart or a gallon or whatever it is, guys, fundamentally, what is volume a measure of? Go ahead. That's, Lauren, closer to density. So it's not the amount, because you could actually have a cup that's completely empty. It's a vacuum, but that could be. So guys, what is volume a measure of? Yeah.
How much space?
Exactly. It's how much space something takes up. How big is it? In a second, we'll bring in, as Lauren mentioned, this idea of how much stuff is in there. But for now, guys, volume is simply an amount of space. So we get cups and quarts and gallons, and we're not going to use any of those. So guys, do you know the metric units? And if you don't, look at your lab. In data step number 3, you recorded a volume, and what were your units? Milliliters. Guys, those are one of the 2 volume units that we're going to use. So one of them is milliliters. But you'll notice that parenthetically, it says centimeters cubed. And guys, let me explain to you what this is all about. Maybe you guys know this. If you don't, let me show you. So guys, a milliliter is actually this. This is how big a milliliter is. But it turns out that if you take a ruler, a cube that is a milliliter is a centimeter by a centimeter by a centimeter. And you all know that volume is length times width times height. So if you take a centimeter times a centimeter times a centimeter, what do you get? 1 centimeter cubed. And so guys, a milliliter by definition is a centimeter cubed, and we'll use those interchangeably because they're the same thing. So you may want to do this to remind yourself that those are interchangeable. So a milliliter by definition is a centimeter cubed. But guys, what if we want to find the volume of things that are bigger? We don't use milliliters. What do we use? We use liters. Did you guys know this? That in the early 1970s, the U.S. tried to switch to the metric system? Did you guys know that? Yeah. Because we're lazy Americans and we don't want to be told what to do. But guys, when I was in kindergarten, I actually had this metric lunchbox. We were like trying to brainwash people into thinking, let's switch to metrics. And they tore down all the speed limit signs and changed the signs to like 80 kilometers per hour instead of 55 miles per hour. And the gas station dispensed gasoline in liters instead of gallons. And they changed all the road signs to Salt Lake was 70 kilometers away. And guys, they spent millions and millions of dollars trying to switch the U.S. to the metric system, and it failed a couple of years later because we were unwilling to change, except for one thing. Can you think of it? Guys, there's only one thing that lasted from our efforts to switch to the metric system. What's the one thing we still measure in metric units? Do you know it? The 2-liter bottle of soda. Have you ever thought about it? Guys, you grab that big bottle, right, a Shasta, and it's a 2-liter bottle. Guys, it's actually almost the same as 2 quarts. But why did the soda companies stick with the liter rather than go back to quarts? Because the liter is slightly smaller and they make more money. Seriously, if they went back to 2 quarts, they'd have to put a little bit more soda in the bottle, and it cuts into their profits. So when we switched back to the quart, they chose to stick, and it's the only thing that stuck. We don't do anything else in metrics except for, you never thought about it, right? The 2-liter bottle of soda. So guys, how big is a liter? Well, you guys know, does anyone have a Nalgene bottle? You do, sort of. So guys, this is about a liter. So most of the water bottles that you guys carry around is about a liter. But guys, technically this is the size of a liter. So this is actually 1,000 milliliters, but guys, this is a liter. So this is how big a liter is. But the thing that's interesting is if you measure this is a box that is actually 1/10 of a meter times 1/10 of a meter times 1/10 of a meter. And guys, there's a name for 1/10 of a meter. It's called a decimeter. And so a liter is actually the same as what we call a decimeter cubed. And we will also use these interchangeably. So guys, you know the answer to the last one because you did it in lab. Guys, what measurement device do we use to measure the volumes of things? Oh yeah, graduated cylinders. Not beakers, not Erlenmeyer flasks because they're not accurate. We use graduated cylinders. So guys, let's now go in the other direction. Let's talk mass and weight. So guys, when we talk mass and weight, you guys know the units, ounces and pounds. You guys know that those are actually weight units, but there is an English mass unit. You guys know what it is? I'll be really surprised if any of you know. Any of you know? The English mass unit. Guys, it's actually the slug. Did you guys know that? It's actually this. Do you get the connection? This is actually a musket ball. And this used to be the definition of mass in the English system, called the slug, because muskets don't shoot bullets, they shoot slugs. And back in, the Elizabethan time, where they were defining English units, they said, let's make a musket ball our standard unit of mass. And because these are called slugs, there is actually an English unit called the slug. We don't use it. So, guys, when we talk about mass and weight, we need a definition. We understand that volume is an amount of space. So, guys, what about mass or weight? When we measure mass, when you went into lab and you measured the mass of the beaker, what were you actually measuring? An amount of what? Weird, right? What are you measuring when you weigh yourself? It is a function of gravity. But guys, what are you actually measuring when you measure your weight or your mass? How much of you there is, right? How much of me is standing on the scale? And if you're dieting, there's probably less of you. And if you ate like I did this weekend, there's probably more of you. But guys, the idea is that when you measure your mass or weight, you're measuring an amount of matter, how much stuff there is. But guys, we don't use the ounce, we don't use the pound, we don't use the slug. So guys, what are the metric units for mass? The gram. And you know what? I want to add one to this, because it's not just the gram. If you need to weigh something heavier, yeah, do you guys know the heavier one? The kilogram. So so that would be 11, so this is going to be 12. Okay, so yeah. So guys, let me catch up now. But guys, as we talk about the gram, this is interesting. So let me do this with you. So how much matter is a gram? And if you want this as a reference, you may want to write this down. Guys, a large paper clip is a gram. That's the mass that is representative of a gram, is about a large paper clip. But obviously they didn't define the gram based on paper clips. So guys, what is the definition of a gram? How much matter is a gram? Did you see it on the board when I was editing? It's the mass of a milliliter of water. So if we could take our little centimeter cube, and if we could fill this with water, again, that's a milliliter. If we could fill this with water, it would have the mass of a gram. So guys, by definition, a gram is the mass of 1 milliliter of water. But guys, obviously that is a ridiculously small amount of matter if you want to weigh something like that. So when necessary, we switch to things called kilograms, which are thousands of grams. So guys, you ready for the aha moment? What has the mass of a kilogram? Thinking about water. How much water weighs a kilogram? A liter. Yeah. A liter is a kilogram. That would be an interesting arrow to draw. So guys, a gram is a milliliter and a kilogram is a liter if it's water. If you had asked that 28 seconds from now, it would have been a beautiful segue. What if it isn't water? And then the answer is we would need to know the density. And that's where we're headed next. Yeah, it's a good question. Darn it, your timing was just a little off. So guys, how do we measure mass or weight? We use a balance or a scale, but in chemistry we call them balances. So guys, are you good on mass and volume? Is that all sitting okay? Okay, so then let's run where Ben was taking us. And guys, let's talk a little bit about this idea. Because the question was, what if it's not water? If it's not water, what does a milliliter of this stuff weigh? And the answer, guys, is in order to figure that out, we need to know what is called density. And guys, this is actually the next thing in your notes. This is the last thing in your notes. We're about 7 minutes away from being done with new material. So guys, what is density? Well, density is a measure of the compactness of matter. The more dense something is, the more of it is shoved into a space. But mathematically, this relationship is actually a ratio. And guys, when you hear ratio, what are we talking about mathematically? What kind of function? It's a comparison, but what does it look like mathematically? It's a division. So guys, anytime we talk about ratios, we're talking about division. And this is the ratio of mass to volume, so it actually looks like this. So guys, let's see what you learned 4 minutes ago. So what would the units for density be if it's mass divided by volume? Go back and look at your chart. What would the units for density be if it's mass divided by volume? Well, what do we measure mass in? Grams. There it is. Guys, mass is in grams, and then the volume is in milliliters. And so guys, our units for density are grams per milliliter. But because you understand that this is a milliliter, what could our other units for density be? Grams per centimeter cubed. So guys, this then becomes the question. So if this is a milliliter, and it is, follow this thought, ready? So if this is a milliliter, and if we were to fill it with water, what would it weigh? A gram. Now guys, what if we could take this same milliliter, and what if we could pack it full of aluminum? This is aluminum, by the way. Guys, if we could pack this cube full of aluminum, what would it weigh now? Well, do this. Would it weigh more or less than a gram? More than a gram. How do you know that? Because aluminum doesn't float. You guys know that connection, right? Anything more dense than water doesn't float. That's how floating works. So guys, if this is more dense than water, it won't float. And so if we take this cube and if we pack it full of aluminum, we know that it's going to weigh more than a gram, because we know that aluminum doesn't float. The question is, what will it actually weigh? If we pack this cube full of aluminum, what will it weigh? Well, guys, we can look it up. Grab your periodic tables. First time this year. Here we go. So guys, now that you've got your periodic tables in hand, we are looking at the front, this side. And then guys, go down here into the lower left-hand corner of your periodic tables. You'll notice that this is the secret decoder key. It tells you what all the numbers are. And guys, if you go down here into the lower left-hand corner, you'll notice in blue it says density. What are the units on our periodic table? What does it say right below it? Density at 0 Celsius, what are the units? Grams per centimeter cubed, and we know what that means because we just learned about that, right? So now, guys, go to aluminum, which is element number 13. And guys, if you go to aluminum, which is element number 13, what is the density of aluminum? 2.7 grams per centimeter cubed. So guys, what that means is if we could take this aluminum and pack it inside this cube, it would weigh 2.7 grams, and that's why aluminum doesn't float, because it's more dense than water. And guys, you actually have access now to the densities of every substance, well, every element that we either have collected or created. So guys, all of this information is available to you on the periodic table. So the question becomes this: what are we going to do with it? So guys, grab your calculators, and we're going to solve some problems with this. Guys, hold on just 1 second. We have a question, and let's think through this. What? No, so looking at and guys, this is important you understand this. Densities are given in grams per centimeter cubed. So the numbers that are on the periodic table are literally the mass of 1 centimeter cubed of the substance. So if you have a centimeter cubed of aluminum, its mass would be 2.7 grams. Is that okay? So all of those masses are grams for 1 centimeter cubed. Is that okay? Okay, so guys, with this information, we're going to solve problems like this. So guys, I would encourage you to write this down with me. It says this. It says you have a metal block that weighs 100 grams and its volume is 8.81 centimeters cubed. If the block is an elemental metal, what is it? And guys, this is something you're going to be doing in lab on Thursday. Which is why we're talking about it now. So guys, again it says this. A metal block weighing 100 grams has a volume of 8.81 centimeters cubed. So 8.8 of those little cubes. The question is, what is it? What is the metal? So guys, in order to, well, maybe we should turn it to a question. Guys, in order to solve this problem, what are we going to do with this information, the mass and the volume? What can we do with mass and volume? Find the density. And if we find the density, how can we then identify the type of metal it is once we know its density? By the periodic table, find the element that has the same density, and that would be the element. You get the idea? So to do that, let's find the density. Write it down with me. So guys, density is mass divided by volume. So now we need some information. We need to know the mass. Guys, what's the mass of this metal? 100 grams. Then, what's the volume of this metal? 8.81 centimeters cubed. Guys, notice how we're solving this. We wrote down an equation. We plugged in our numbers with units. Now, guys, at this point, you need to do the math. So you've got 100 divided by 8.81. Grab your calculators. I'll grab mine. And guys, I get 11.35074. Go ahead, Lauren. It's a great question. And the answer is because that's what density is a representation of. So density is a representation of the number of grams in a given number of centimeters. And so the idea is that when we divide these, what will the units be? Well, the units stay. The units stay grams per centimeter cubed. So what we now know, Lauren, is if 8.8 centimeters cubed is 100 grams, then 1 centimeter cubed is 11.35 grams. So the ratio stays the same because the units don't cancel. So guys, I'm hoping you have a problem with my answer. What's wrong? Significant digits. So guys, how many significant digits are in 100.0? So the 1 is significant. What about the final 0? Significant. What about these guys? Trap. So that's 4. What about 8.81? That would be 3. So guys, that means we get 1, 2, 3 in our answer. So that would be 11.4 grams per centimeter cubed, and that is the answer that we're allowed to report. So the density of this metal, the 3 significant digits, is 11.4 centimeters cubed. So now, guys, we've got to do a little scavenger hunt and figure out what this metal is. I'll tell you this much. Look in this region down here. Did you find it? Guys, it's not going to be perfect, but it's going to be close. And what's the closest we can find? Lead. Guys, it turns out that this metal is actually lead, which has a density of 11.34 grams per centimeter cubed. It's not perfect, but it's the closest, and that's the element that we understand it to be. So guys, one of the things that we can do with this information is we can calculate density. The other thing we can do, though, is we can actually solve for mass or volume. But if we want to solve for mass or volume, we need to be given the densities. So guys, try this one. It says, what is the mass of 1,250 milliliters of aluminum? So guys, this is the question that we're asking. Here's 1,000, here's 100, here's 100, and then here's 5, 10, 10, 20, 30, 40, 50. So guys, this is 1,250 milliliters. The question is, if this was made of aluminum, what would it weigh? Well, guys, try this. If this was made of water, what would this weigh? 1,250 grams. That's the point. The density of milliliter weighs a gram. So, guys, if this was made of water, it would be 1,250 grams. But it's not. We're saying that it's made of aluminum. And the question is, what would this weigh if it was made of aluminum? Well, guys, again, to answer that, we need an equation. So we go here, and we start with density as mass divided by volume. Guys, just get used to writing down equations. By the way, you'll never have to memorize equations in this class. We'll always give them to you on the test. Now, guys, in order to solve this, what are we solving for? What's our goal? What are we trying to figure out? We're trying to figure out the mass, right? So guys, if we're solving for mass, that means we need the density and we need the volume. So where do we get the density? Periodic table. You're starting to get it. So guys, find again element number 13 on your periodic table. We've already looked at this, but let's do it again. So guys, the density then of, what is it? Oh, I have it in my notes. Never mind. No, so element number 13, what's the density of aluminum? 2.7. So guys, it's 2.7 grams per milliliter. Then what's the mass? We don't know, that's our X. You guys remember that magic moment in like intermediate math 1 where you learned that you can replace anything with X? And you felt like a god. You're like, X. Now guys, what's the volume? 1,250 milliliters. I would suggest that you're about to do the second most powerful thing you learned in secondary 1, or actually intermediate 1. Remember cross multiplying? Oh boy, that was fun, huh? Guys, in order to solve this for X, all we've got to do is cross multiply, right? So 2.7 times 1250. But we need to watch significant digits. How many significant digits in 2.7? 2. How many significant digits in 1250? Be careful. How many there? 3. That 0 is not a final 0 after the decimal. So that's only 3. And so guys, we get 2 and 3. That gives us 2. And this number to 2 significant digits is 3,400 grams. So guys, if this thing were made of aluminum, it would weigh 3,400 grams times the 1250. Yep. And guys, I don't know if you know this trick, but let me share this with you. This will save you in college. Guys, you maybe you look at this and you're like, I have no idea how to solve that. You're like, it's numbers and it's units, and you're like, oh my gosh, I don't know what to do. But guys, what about this? Could you solve, let's go. Can you solve that? What divided by 12 is 3? 36. How did you come up with 36? Well, you cross multiply. Guys, that is exactly the same problem with uglier numbers. So if you ever get into a point in a mathematical process where you're looking at something and going, I don't know how to solve that thing, guys, just make up your own simpler equation with easier numbers. And if you can figure out how to solve this, you can solve that. It's just uglier numbers. It'll save you. So guys, density and mass and volume. Do you have questions or things you want to talk about? You guys okay? Okay. So guys, if you're good, here's what we're going to do. Take your class notes, slide them to the side. Don't get rid of them. But guys, now bring into your field of view your lab and the extra copy of it that I gave you. And guys, this is going to take as long as you need. But let me explain to you the goal. Guys, understand that when you turn in lab work to me, it is not you grading it. You do not get the benefit of the doubt. It's either done right or you lose points on the lab. Now guys, understand homework is a very small portion of your grade. Labs aren't. Labs are a ton of your grade. So you want to be doing your labs very, very well. So guys, with that said, here's what we're going to do. We are going to talk about what should this lab look like. Guys, understand these are not suggestions. These are not things for you to consider. These are not, hey, check this out and see if it fits your personality. Guys, this is what these labs are to look like. I'm training you up as a person that can communicate in the language of science. This is the way scientists communicate lab information. So this is what your lab is to look like, and your goal is to bring what you're doing into alignment with this. So guys, in that spirit, I offer you this. So guys, this is our lab. The first thing that I would encourage you to do, because this is where you started writing stuff down, is check out the data section of your lab. And guys, what I would do is this. I would grab the lab that you've already started on, and I would be making editing marks. Then eventually, if you need to copy this back over to the blank lab to make it look good, you can do that. But guys, this is how I'm going to grade your lab. I'm just going to be really transparent about this. So guys, the first thing that I'm looking for, and I cued you on this when we did the pre-lab, I'm looking for units. If you do not have units on all of your numbers, you're not okay. And obviously the units need to be appropriate given that you understand that masses are grams and volumes are in milliliters. Guys, stop me if you need. You okay there? Okay. Then guys, the next thing that I'm going to be looking for as I grade your labs are your numbers. And guys, understand you don't get to just change your numbers if these are wrong. So, if your numbers are not recorded properly, what I'm going to have you do on the lab that you turn in is I'm going to have you circle your mistakes. Do not change your data. But if you circle your mistakes, that's telling me that you understand this was a mistake, and I will give you credit for it as if you did it right. So guys, this is what I'm looking for. All of your masses should be recorded to 2 decimal places. So if one of your masses is 24.1, you're not okay. So guys, all of your masses should be to 2 decimal places. If they are not, don't just magically add numbers. That's cheating. Guys, if your masses are not to 2 decimal places, circle the places where they're not, and I will give you credit for them this time because you learned from your mistake. Now, guys, your volume. Your volume should be measured to 1 decimal place, not 2 and not 0, 1 decimal place, because our graduated cylinders measure in whole milliliters and you estimate to tenths. So guys, if your volume is not to 1 decimal place, don't cheat, circle it, and I will give you credit for it this time. Absolutely. Yeah, let me do this. I'll give you 2 copies, one that you can jot notes on and one you can use to perfect it later. So guys, any questions about your data and what the expectations are? You guys good? You're all okay? Guys, please ask if you need. I want you to do well on this first lab. Good? Okay. So in your calculations, it should look like this. This had better be there. Oops. Because guys, this I gave to you when we introduced the lab. So if this isn't there, you need to question whether or not you're paying attention in the first place, because all you had to do is copy that off the board with me. So guys, anytime you find mass by difference, you always set up like this. And guys, let me tell you right now, I looked at some of your labs and some of you wrote this horizontally. That's not okay. If it doesn't look like this, it's wrong. Okay, it's got to be mass of beaker and salt minus the mass of the beaker gives you the mass of the salt. There's a line, there's a subtraction, it's in columns, it's all well done just like this. So guys, if you've done, and I know this sounds crazy, but if you've done anything other than this and you're thinking to yourself, this will be fine, it won't. It's got to look like this. Yeah. It has to be the words. You have to write this down. I can't stress this enough, guys. It's got to be this. And this isn't me being weird. This is the way scientists have agreed to communicate this information. And I know that some of you are coming out of math backgrounds where anything goes so long as you get an answer, and that's ridiculous to begin with. Guys, it's got to be this. There's a format that you're learning. Then what you're going to do is you're going to skip some space. If you didn't skip space, you're not okay. If this is on the left, you're not okay. Because here in the US, we read from left to right. So what you're doing is you are telling your reader, here's the math that I'm going to do, here's the math. So you set it up and then you solve it. So you read left to right. Then guys, on the same lines, carrying this across, lining up your decimal places, you do the subtraction. Obviously, your numbers will be different than mine, but this is the format. Okay, now guys, looking at your labs last time, a lot of you got this right because you copied it from me. And then you got down to the second calculation, which was the mass of your recovered salt, and all you wrote down is that. That's not okay. Guys, this calculation, because it's mass by difference, also needs to be represented in the same format. So to find the mass of your recovered salt, it goes mass of the evaporating dish, the watch glass, which you can abbreviate WG, and the salt, minus the mass of the evaporating dish and the watch glass, results in the mass of the salt. Notice again that you're skipping space, lining things up, plugging in your numbers, and doing the subtraction. Also, guys, don't forget units on your numbers. Those have got to be there as well. So guys, let me get all my scribbles out of the way. Let me zoom back in and let me give you the time to get this all dialed in. Yeah, go ahead, Mark. Because we read top to bottom, it does. Yeah. So guys, do you need more time with this? And I'll leave this up here. Do you have questions about the subtraction? Then let me do this with Mara, just to wrap, as Mara was asking. So guys, what about the percent error? And this is the scoop. This is what this has got to look like. You write down the equation, then you plug in your numbers. Guys, the measured amount is the amount that you recovered. The accepted amount is the amount that you started with. Then guys, be careful. Remember that you do the subtraction first and then the division. And many times your subtraction, because you're watching decimal places, will limit your significant digits when you do the division. So be careful on that math. You may even want to add another step where you show the result of the subtraction and then the division, so that you are careful with significant digits. But again, guys, this is the structure and the format that we're looking for. Then on the back, you've got your conclusion questions. The expectation is that you're writing incomplete sentences and you're communicating thoughts clearly. And guys, legibility matters. If I can't read it, I won't grade it. It's funny, I sat down, this kid came to me and said, hey, would you please read over my conclusion questions? And I sat down to read over them, and I asked him, what does this say? And he couldn't read it. And he expected me to. So guys, be careful as you're writing stuff. Represent yourself well. And I know most of you understand this, but guys, one of the things you got to understand is that the way that you structure and format the things that you write will open and close doors for you. It doesn't matter how smart you are if you look stupid because your handwriting sucks. Seriously. Guys, you've got, whenever a teacher, a professor, an AP grader, whenever somebody reads your work, they don't read the words first. They look at the product. And if it looks like a train wreck, they assume you're stupid. Guys, you want to give everybody that reads your stuff every reason to believe that you're intelligent, which means structure, organization, penmanship, all of that stuff. So, guys, any questions about any of this? You divide by 102 and then multiply by 100 to make it a percentage. Yep. So guys, questions about the lab? Y'all okay? Okay, so let's lay this out for you then. We now have 30 minutes, which is wonderful, and you have two things to work on. One of them is perfecting this lab. And guys, again, I've given you a blank copy of this lab. So if you take your present lab and hold this at arm's length and go, ugh, there's like eraser crap everywhere, if you have anything X'd out, guys, don't turn that into me. Guys, this is a high quality product. So if you look at this and you go, ooh, that makes me look stupid, take 7 minutes and transfer it to another sheet of paper. So guys, the expectation here is this is your very best work. Tell you what, don't give this back to me. Take this home with you tonight. I think some of you are going to get home and go, yeah, I should probably recopy. I don't want these back. Take them home with you. So guys, here's the rest of the day. 30 minutes, you've got two things. Oh gosh, sorry. 30 minutes and two things to do. One of them is you have a homework assignment. Go to the homework section of your notebook. Have any of you managed to lose the homework packet yet? I got extra. You guys, did I tell you this? There's always extras over here. So guys, we are on assignment number 3. It's the very last page. You'll notice that there are only 4 problems. So one of the things that you could be working on in the next 30 minutes is homework assignment 3, which is the last homework assignment for the unit. Guys, the other thing you can obviously be working on are your labs and getting those dialed in. So guys, if you get done with your lab write-up today and you would like to turn it in, it goes in here. Guys, the only thing that goes in these baskets is homework, or is lab work. So when you're done with your lab, you're welcome to turn it in. By the way, guys, if you don't choose to turn it in today, it's due when the bell rings Thursday morning. It's not at the end of class, it's when the bell rings. So if you're sitting there finishing your conclusions as I'm picking this up, it's going to be late. So you need to walk in here on Thursday with them done. So if you want to turn your lab in before you leave, if you get it done, there's the basket. Guys, you've got homework to work on. We got plenty of stuff to do. I would love to help. Invite me into your conversations and let's get some stuff done. Go get them.